Greetings, programs. Welcome back to another LeetCode adventure. Today we'll be doing problem number 3. Problem number 3 is the longest substring without repeating characters. So let's go ahead and bring us over to that one right now. Alright, so problem number 3, longest substring without repeating characters. It's a medium problem. Given a string S, find the length of the longest substring without duplicate characters. So let's say that we're given a string ABC, ABC, BB right here, right? They want you to find the longest substring, so ABC, and tell it return its length, right? And if we do BB, that's only ever going to be this one little B with the longest length, okay? If we do PW, WKEW, they're going to say the longest length one is actually WKE with a length of 3. It couldn't be WKEW because it has 2 W's, so it's not unique. It could be KEW, but it also has a length of 3, and since you came across WKE first, that's the one you would take. Now you could say PKEW, but that would be a subsequence, or PWKE, sorry. But we're looking for a substring, so that means it has to be like a little continuous piece. Okay, so let's see here. The length of our string is going to be between 0 and 5 to the times 10 to the 4th. Consists of English letters, digits, symbols, and spaces only. So that means that we're dealing with ASCII. That does make the problems a little bit simpler. In some cases, UTF-8 is a pain in the butt. But we're going to be solving the problem in Rust. And in Rust, all strings are UTF-8 anyways. So there's a couple things that we can do. It'll slow us down a little bit if we handle UTF-8, but we could. But if we want to go for blazing speed here, we would go ahead and just handle the ASCII characters. And I'll show you why, or I'll show you how that makes it faster at the end. So let's go ahead and get started here. Let's expand the code out. So we're going to find the length of the longest substring. Okay. So what do we need first? How are we going to do this? So to find the longest substring length, we're going to want to... we got to figure out what a substring length would be. So we need a window, like a sliding window through this array. To do that, we're going to create a window that's going to define left and right. So... now, this is different from like a binary search left and right, but it's kind of similar in that we're using 2 pointers into an array. And since we're going into an array in Rust, it's going to be a U size, because that's an index. And we're going to have our left and our right. U size equals 0. There we go. Get my fingers set on the keyboard right. Okay. And we need to keep track of our maximum size, if I'm not mistaken. So we need a max variable. So let max, that's going to be an I32. I'm going to set that to 0. Right? Okay, so now we have our I32. Okay, so now we need to get the chars out of the string. And in Rust, you can do that just by telling the string, hey, I need the chars. So let's get them. Let chars be... no, not... what are chars in this one? It comes out as a vec, I think. A vec of chars. Because we don't want to... get the iterator, which would be s.chars, right? We just want to get a vector of the chars to go through. That way we can control where in the vector we're looking. And you do that by just saying s.chars.collect. Okay, and then we're going to go through here. We're just going to say if our chars length is less than 2, right? Then we're going to return the char's length as an I32, because it'll be a U size, but we'll return it as an I32 because that's what they want here. And what this is doing is if you're passed a string that is just no characters in it, right, then we're going to return 0 because there's nothing there. If you're passed a string with 1, then our window is only 1. If you're passed a string of 2, however, we have to find out if our window is 1 or 2 in size. So at that point, we can't do this. But this is just an early opt-out of the function and give a quick answer without having to jump through everything. All right, so now we're going to set our loop here to go through the array, right? So now we're dealing with a vector. So while the right-hand side of our window is less than the chars.length. All right, what are we going to do now? We need to have a way of marking down what we've seen. We could do like a set to say we've seen it or not. Let's just do a hash map. We can count how many times we've seen it then. So we could do use std collection. Is it collection or collections? We'll find out. Hash map. Okay. So now we got our hash map that we can use. Let's go ahead and just say let this be our visited list. And that's going to map a chars. I guess that's char. Oops. That's going to map a char to what? I32, I guess. That could be less. I don't think we're going to see more than like one at a time with our sliding window. I mean, it could end up just becoming a Boolean value, in which case you just use a set. But for now, we're just going to do I32. We could pull it down to an I8 even, probably. Let's do that. An I8. And then we'll set that equal to a hash map new. All right, so that's our visited list. Now, we don't know what characters have or haven't been visited yet. So whenever we see a character, if we haven't seen it before, we should add it to the list, right? So if it hasn't been visited, visited dot contains key. All right, we're gonna jump to Rust docs here so I can make sure I got this right. Rust doc hash map. Let me check, make sure you guys can see what I'm seeing. Yeah, okay, cool. So Rust doc hash map. Yeah, contains key. There we go. Returns true if map contains value for a specified field. Cool. We're gonna leave that up. We'll come back to that if we need it. Contains the key. And chars right, because that's the key we're looking at. All right, and if it doesn't contain it, we're going to say visited dot insert. And we're going to insert our chars right. And that's copy, so no worry about that. And then we'll just say, hey, it exists. Okay, so that's good. So now we have to move through our list or through our array. Okay, so we're just gonna move through it every loop, and move the right of our window 1, because we'll check the new character and deal with it. But now every time we check a character, that needs to be in our loop. Every time we check the character, we need to also check to make sure that we have the maximum of our setup. So max equals our window left to right. So std compare max of our max value and right minus left. As in I32. Okay. So there we go. We get the max, and then we just return the max. All right. So that's going to keep increasing our right-hand side of our window, and just keep making it bigger. But our left-hand side needs to move. So when does our left-hand side move? Our left-hand side moves only when we've noticed that we have a value that we've already seen, right? So what we need to do is that every time, now this one here adds new characters to our visited map. But now, so this one here you can basically ignore. If we could fold it up, I would, but we can't fold it up here. So what we need to do is basically say, hey, we've seen a new character, mark it as seen, right? And this is what happens when our right moves to the right. So if we let if we let some value be our visited dot get, do we need mutable? Yes, mutable, so we can change it because we want to increase the value that it has. So we'll take val that's going to become a plus equals 1 because now we've seen it again, or we've seen it for the first time. But either way, we're just incrementing how many times we've seen it. Okay. Now, when we do that, though, we need to know if we've seen it before. If we've seen it before, then we need to loop through, and shrink our window down until we haven't seen it before, so that removes it from our window. So let's go ahead and handle the left side moving. So how do we say that we get it uniquely? I guess we could say that if let some value equal visited dot get mutt again, because we're going to change it. And chars right. Then, no, not right. We're on the left-hand side this time. We're at the beginning, moving the beginning of the window over. Then we could say, what? Star val minus equals 1. And then we got to move the left, right? So we move the left. Move the left over 1 to the right. Plus equals 1. Okay, but now we gotta do that in a loop. So while oh, but that's 2 different values because we have to keep an eye on the right-hand side and say, hey, right-hand side of my window. So what we're looking at is this. Let's go ahead and make sure everybody's in my head. So let's say that we have A, B, C, A, B, C. As we come through, our right-hand side is looking at A, right? And our left-hand side is looking at A. So I'll mark that with a little, let's see here. We'll put what we're looking at with these angle brackets. Okay. So as we come through, we move our right and we expand our window. We move our right and we expand our window. We move our right and we expand our window. Now, we have seen A before, so that visited is greater than 1. Right? Now we've seen it twice. So now what we have to do is we have to move our left, decrease what we've seen, but then check our right to make sure that we're good to move on. Once we're good to move on, then we can start moving our right again. Because now we're sure that our sub-window here is unique. So what we really need here is a unique and that's just going to be a bool. We're going to set it that it's unique as false until we prove otherwise. So then our check for unique being false would just be if let some value equal visited dot get the chars of our right. Yeah, that's good. And then if the value of that char is less than or equal to 1? 0 or 1. I mean, I guess in honesty it's going to be 0 or 1, so it could actually be U8. Anyways, we're going to say that our unique equals true. Right? Otherwise, while not unique, we want to decrement and move. Yeah, that's it. Okay. So that seems good, but now we need to then we got to check unique again. So we're really going to take 1, 2, 3, 4, 5, 6, 7. Why? I'm going to do that. Can we shorten this? Can we make this, you go in it once, and we decrement it. We could shorten that a little bit. Okay, so if we do this here, and we say move this here, and we'll pop that up to here, right? So this is a unique pass, false. If, because we're already getting the value here, so if star val is less than or equal to 1, then it's unique. Unique equals true. Right? Yeah. And then we can pass through. But if we hit 1, it's going to say it's not unique. And then while not unique, it'll come in here and decrement 1, removing to the left, and then it'll check for uniqueness again. And while it's not unique, it will... Yep, okay, cool. Yeah. I like that. I like that a lot. Okay, let's run this and see what we're getting. So something about cars instead of chars. Bring that down. Line 17. Oh, okay. Yep. We had cars instead of chars. Cannot assign twice. Our max needs to be mutable. Okay. That's fine. Off by 1 each time. Let's see here. So let's take this one here, right? So right is 0, left is 0. You get 0. They want 1. Okay, so we need to add 1. Okay. That's fine. And then let's just make sure here. So left is 0, right is 3. No, right is 2. 2 minus 0 is 2, but they have got 3 characters plus 1. Okay, yeah. Let's see if that does it. All right, we solved it. So that's our solution there. Now we just need to go through and check. We need to go do some test cases before to make sure that we're not going to make problems. So test case 4 is what happens if we just have nothing. Test case 5 is if we have one thing. E. Test case 6 will be if we have... this is a... blah, 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 blah. String of nonsense. Period. Okay, run that, see what we get. Okay. I think I'm happy with that. Let's see what we get when we submit it now. And we're in. All right, 2 milliseconds. All right, so that's not too bad. It's not perfect, but it's not too bad. Memory. Oh, we're a bit high on the memory usage. Now, let's go look at our solution and see why. Why are we high on the memory usage? So if we look here, so this was the ASCII thing I was talking about. So what we're doing here is we're creating a whole vector, and we're taking an extra bit of time looping through to collect these characters from the string and putting them into a vector. That's slower, but with UTF-8 characters, everything's not a byte. So some of them might be 2-byte characters, they might be 3-byte characters. So really you can't handle them as you would ASCII. But since we know that it's ASCII, and only because we know that it's ASCII, I think that string has the ability to let us deal with it in bytes instead of characters, right? So as string as bytes, yeah. So as bytes, so we can get these as individual bytes. Now that's different from the characters, but we can get it as bytes, right? And what does that return me? A reference to a U8. So it's a reference. We also then aren't making a brand new vector of data, right? So, and U8. So now we've decreased our memory requirement. We've decreased having to go through the array by an order of n, right? So now we're only going through the array order of n times instead of 2n. So that should decrease our runtime and decrease our memory requirement. Let's test it. Make sure that we did that right. Okay, we didn't do that right. Contains T chars, right. What's it complaining about? Expected and char found and U8. Okay. This here needs to be a U8. So we're going to store U8s in it. Okay. Now run that. So we're going to store bytes in and reference the bytes. There we go. And now we passed. We passed all of it. Green, green, green across the board. Okay, submit that. And let's see if that speeds us up. Now we're slower, but our memory is less. I think what we're hitting here is the fact that there's a lot of people online, probably. Let's do one more submit just to see if that decreases the speed. Yeah, because now we're down to 3. I think we're just hitting a lot of people online. So that should be faster. That should be faster now that we aren't going through twice. So I'm going to call that done. I mean, we solved it. It's accepted. Test cases all passed within time. Our memory footprint is pretty low. We're like right in the middle. There's probably ways to make it less. Like if we didn't use hash map, maybe if we use a set. But overall, I'm happy with it. It doesn't use that much more memory to solve the problem. So yeah, I think I'm good with it. All right, so we're going to call that done. And move on. Thanks for joining me. End of line.